Hi, good morning and welcome to today's class. In today's class, we'll be looking at number-based system. We said number-based system can be said to be the process of counting numbers in groups. Before we move further into today's topic, I'd like us to look at some of the objectives of this class. That at the end of the class, the students ought to have learned 1. How to convert numbers in base 10 to other bases. 2. Convert numbers in other bases to base 10. 3. Convert decimal fractions in other bases to base 10. 4. Carry out operations involving addition, subtraction, multiplication, and division of numbers in different number bases. 5. We also learn how to solve equations involving number-based system. And 6. The application of to apply the processes of the number-based system in computer programming. The process of counting in groups can be termed as number-based system. And we said the process of counting in groups of twos, the process of counting in groups of twos can be said to be the binary number system. Binary number system. And we say the binary number system has just 2 digits, which are zeros and ones. So in the binary number system, you have zeros and ones, and it is also said to be the base 2 number system. Also, we have the base 3 number system, which I will just type base 3 number system. The base 3 number system is made up of 3 digits, which are zeros, ones, and twos. So, a base 3 number system is made up of just these 3 digits. Also, we have the base 4 number system, which is also made up of 4 digits, which are, you can only find zeros, ones, 2, and 3s in a base 4 number system. We also have the base 5 number system. We have the base 5 number system, and in the base 5 number system, it's made up of digits 0, 1, 2, 3, and 4. Also, in the base 6 number system, we have digits 0, 1, 2, 3, 4, and 5. Also, in the base 7 number system, we have it to comprise of digits 0, 1, 2, 3, 4, 5, and 6, and so on and so forth. But let's look at the main number-based systems that we talk about. We have the base 2, we have, which is made up of zeros and ones. We have also the base 8, which is made up of zeros, ones, 2, 3, 4, 5, 6, and 7. The base 8 system is also referred to as the octal base system. We also have the base 10. The base 10 system, which is the base system used by we humans, and is made up of 10 digits, which are 0s, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and it's also said to be the decimal base system. Okay, we also have in focus the base 16 number base system, and the base 16 system can be said to be alphanumerical, meaning it is made up of both letters and numbers, while we have digits 0 to 9 to take care of the first 10 digits in the base 16. We also have, in continuation, we have A, B, C, D, E, and F to make up the other 6 digits. So in a base 16 system, these are the digits you can find, and we said it is also known as the hexadecimal number base system. Having known the different kinds of number-based systems that we have, it is also good that we know how each of these operates. Like the base 2 system is mostly used by our computer devices, because most of our circuits in the computers are most of them are made up of circuits. Most of the circuits in our systems have just 2 operations, which is the on and the off system. So in electronics, 0 is represented as the off state of the device, while 1 can be represented, is used to represent the on state of the device. So the base 2 system is mostly used by our electronics and by our electronics gadgets at home. Other base systems are also used by other systems, but the one mainly used by we humans is the base 10, which I also call the decimal base system. This is the one understood by man, and in order for us to communicate very well with our electronics, we need to know how they see whatever instruction that is being given. So that will lead us into conversion from base 10 to other base systems. So we need to know how this conversion is being done. So let's look at conversion of numbers in base 10 to other bases. This is the method applied in one serves for all. Now we have example 1, which says we should convert 25 base 10 to a number in base 6. In order for us to convert 25 in base 10, which is the decimal system, to a number in base 6, we need to use the long division method by dividing 25 and its multiple repeatedly by 6. So, using the long division method, I'm going to keep dividing 25 by the base I'm to convert it to, which is base 6. You keep dividing 25 and the multiples you will get by 6, and the remainder is written on the right hand side. And it goes this way. 6 into 25 is said to be 4 remainder 1. Let me use R to represent remainder. I will also divide 4 by 6, and 4 divided by 6, it cannot, so I'm going to write 0 remainder 4. This is how you keep dividing until you get to 0. And what is the equivalent of 25 base 10 in base 6 is said to be the remainders written from the bottom to the top. So we'll have it at 25 base 10, we'll say is equivalent to 41 base 6. That is 4 groups of 6 squares and 1 multiple of 6. Example 2 says we should convert 31 base 10 to base 2, base 6, and base 8. So first of all convert it to base 2. So I'm going to use the long division method. Divide 31 by 2. 31 divided by 2 is going to be 15, remainder 1. Keep dividing by 2. 15 divided by 2 is said to be 7, remainder 1. 2 into 7 is said to be 3, remainder 1. 2 into 3 is 1, remainder 1. 2 into 1 is 0, remainder 1. So therefore 31 base 10 is equivalent to 1, 1, 1, 1, 1. That's 1, 2, 3, 4, 5. 5 groups of 1 to base 2. Remember what I told you earlier on, that in base 2 you only see digits of zeros and ones. B says we should convert till 31 base 10 to base 6. I'll also do this by dividing 31 by 6, and 31 divided by 6 is said to be 5, remainder 1. 6 into 5 is said we cannot, so this gives us 0, remainder 5. So therefore 31 base 10 is equal to 51 base 6. Also, we have to convert to base 8. So 31 base 10 to base 8. So this becomes 31 divided by 8. 8 into 31 is 3 times, remainder 7. 8 into 3, we cannot, so we say is 0, remainder 3. And taking our remainders, it gives us the equivalent in base 8. That is 31 base 10 is equal to 37 base 8. Also, we have to convert the following numbers to the given bases. So we have 117 base 10 to be converted to base 6. We'll also use repeated long division to find its equivalent in base 6. So this is 117 divided by 6. 6 into 11 is said to be 1, remainder 5. 6 into 57 is said to be 9 times. For 9 times 6 is said to be 54. So it is 9 times remainder 3. When you subtract 54 from 57, you have 3. Also, you keep dividing. 6 into 19 is said to be 3, remainder 1. For 6 times 3 is 18. 19 minus 18 is 1. 6 into 3, it cannot. So this becomes 0, remainder 3. So that 117 base 10 is equivalent to 313 base 6. Also, we have 89 base 10 to be converted to base 4. You also divide 89 divided by 4. 4 into 8 is 2, remainder 0. 4 into 9 is 2, remainder 1. Divide by 4 again. 22 divided by 4 is said to be 5, remainder 2. For 5 times 4 is 20, and 22 minus 20 is 2. Divide by 4 again. 4 into 5 is 1, remainder 1. And 4 into 1, we cannot, so we say is 0, remainder 1. So our equivalent in base 4 can be said to be 89 base 10 is equal to 1121 base 4. Also, we have to convert 175 base 8 to base 10. I have showed you how you can convert from base 10 to other bases. Now let's see how we can convert from other bases to base 10. We can do this using the expanded method. Remember, in our previous class, in SS1, you were told that this can be represented as 1 times 8 raised to the power of 2 plus 7 times 8 raised to the power of 1 plus 5 times 8 raised to the power of 0. That is, this is 1 times a multiple of 64. Why this is telling us that it is 8 raised to the power 1 in 7 places. So in converting from this other basis to base 10, we use the expanded method to expand it and thereafter simplify, and when you sum them together, it gives you its equivalent in base 10. So this can be said to be equal to 1 times 8 squared is said to be 64 plus 7 times 8 plus 5 times 8 raised to the power 0 is 1. For any number raised to the power 0 is said to be 1. So this becomes, multiply them out, 1 times 64 is 64 plus 7 times 8 is said to be 56 plus 5 times 1 is said to be 5. And when you sum them up together, what will you get? 64 plus 56 plus 5. No need of writing the second addition. So that this becomes, this is 10, 15, 5 carry 1, and this is 12. So therefore, this is said to be 125 base 10. So in converting from this other basis to base 8 to base 10, you use the expanded method and then you simplify. Let's look at another example, which says we should convert 110011 base 2 to base 10. We also do same by writing this in the expanded method. Now, how do you know which is being multiplied by what multiple of 2? In your junior elementary, you were told that you number them from beginning from the right to your left, starting with 0. So this will take the power of 0, this will take the power of 1, 2, 3, 4, and 5. Or you can look at the numbers and the power to which the base will be raised will be equivalent to the number of digits after that digit in question. So for example, this becomes 1, which is the first digit, 1 times 2 raised to the power 5 plus 1 times 2 raised to the power 4 plus 0 times 2 raised to the power 3 plus 0 times 2 raised to the power 2 plus 1 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. So when you simplify this, this becomes 1 times 2 raised to the power 5 can be said to be 2 times 2 times 2 times 2 times 2. That is 2 multiplying itself in 5 places. And this is said to be equal to 32 plus 1 times 2 raised to the power 4 can be said to be multiple of 2 in 4 places, which is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So 2 raised to the power 4 is 16 plus 0 times 2 raised to the power 8, 2 raised to the power 3 is 8 plus 0 times 2 raised to the power 2 is 4 plus 1 times 2 raised to the power 1 is 2 plus 1 times 2 raised to the power 0 we said is 1. Then you multiply out, this becomes 32 plus 16 plus 0 times 8 is 0 plus 0 times 4 is 0 plus 1 times 2 is 2 plus 1 times 1 is 1. So this is equal to 32 plus 16 plus 2 plus 1. This is equal to 32 plus 16 is 48. 48 plus 2 is 50, and 50 plus 1 is 51 base 10. Also, we are asked to convert 119 base 10 to base 4. I will leave this as a take-home assignment for you to try. What you have to do is, you have to use the long division method to divide 119 by 4 to get its equivalent in base 4, and you do same dividing it by 8 to get its equivalent in base 8. That brings us to the end of today's class. At the end of this class, we have been able to convert numbers in base 10 to other bases, as well as we have seen how to convert numbers in other bases back to base 10. In our next class, we shall be taking the third objective, which says we have to convert decimal fractions in other bases to base 10. Thank you very much for paying attention to this class. Hope to see you in our next class. Thank you very much.